Differential and integral operations 4, we already did part A and part B. Now we will work on curl of FA and divergence of A cross B. That's part C and part D. Using subscript summation notation, we will verify these identities. So let's start with curl of FA. Okay. Now, how do we write curl in a subscript summation notation? It is epsilon ijk ei hat, the jth component of the del operator, del xj, applied to f k component of the vector field A. So this is going to be epsilon ijk ei hat multiplied with, now we're going to operate this del xj on fak. So this will, the first we will operate it on f, so it's ak comes out, del f del xj, and then we will operate it on ak, so it's epsilon ijk ei hat, f comes out, del ak del xj. All right. Now, we have to understand what these are. So del f del xj is del f del xj ej hat's jth component, and ak is ak ek hat's kth component. So that's what we realize here. And this is just another cross product. So f multiplied by cross product epsilon ijk ei hat del xj ak, that's f multiplied by curl of A basically. All right, so that's equal to epsilon ijk ei hat. Now we're looking at del f del xj ej hat's jth component, and this is multiplied with ak ek hat's k component, and the second term plus epsilon ijk ei hat del ak del xj. This is multiplied with f. All right, now we can realize that what we have here is this is gradient of f. So we have gradient operator acting on f. That is, so this is basically epsilon ijk ei hat, jth component of a vector, kth component of a vector, that's the cross product. So gradient of A cross product with vector A. Plus, then we have f multiplied by the curl of the vector field A. So this is now curl of the vector field A. That's this term here. And therefore, we reach the conclusion. So we can say that curl of f times A vector field is f multiplied with curl of A and added to it gradient of f cross product with the vector field A. And let's check if this was the suggested answer in part C. It indeed was. So this is the conclusion from this scientific subscript summation notation analysis. Now let's look at divergence of A cross B. Here I have the del operator, del xi ei hat. That's the del operator. We have a dot product with A cross B vector. So this is A cross B vector j component in ej hat direction. ei hat dot ej hat is Kronecker delta ij. So we have del xi, and that's multiplied with A cross B's j component, and this is basically I has to be set equal to j del xi A cross B's ith component. Okay, now we have to write A cross B's ith component. So del xi, and as for the cross product, we have epsilon ijk aj bk. This is the ith component of the cross product A cross B, and we can also write this as, because we have the del operator acting on two vector fields, epsilon ijk bk del aj del xi. That's the first term in the product. And then we have plus epsilon ijk aj del bk del xi. All right. So for the first term here, we can write this as, note that we can do cyclic permutations of these I, j, k indices. So let's remember here we have I, j, k, and that's the plus one direction. So epsilon ijk is equal to epsilon kij. So this is epsilon kij bk del aj del xi. Then we have aj, and you can notice that ijk or jki, it's the same thing, and kij is the same thing as well. So we can do epsilon jki del bk del xi. So here we have the kth component of the vector b. This is bk ek hat's kth component. And epsilon kij del xi aj is curl of a's kth component. And then we have vector A which is AJ EJ hat's J component here, AJ, and then epsilon JKI now instead of epsilon JKI, let's write epsilon JIK, and with an odd number of permutations, we have to introduce here a minus sign so that this becomes epsilon JIK del del xi applied to bk, which is curl of b. So this will be curl of b's jth component, and this is a minus sign here. And now I'm ready to read what I have as the answer. This is vector b, kth component of two vectors multiplied implies this is a dot product, b dot curl a minus jth component of two vectors multiplied dot product a dot curl b. So this is the divergence of A cross B. And let's check if this is the right answer. Divergence of A cross B is B dot curl A minus A dot curl B. So that's exactly what we have found here. Okay, so in part C, we worked on curl of FA. That's epsilon ijk ei hat del del xj FA's kth component, which is F times AK, because F is a scalar field. And then we can apply this differential operator on the product of these two functions. One is scalar, one is a vector field. Epsilon ijk ei hat, AK is left alone, del F del xj, and then F is left alone, del AK, del xj. Now, for del F del xj, this is the jth component of del F del xj ej hat, and for AK, it's the kth component of AK ek hat. So this is representing vector A, this is representing gradient of F, so we have epsilon ijk ei hat, jth component of the first vector, kth component of the second vector, which is gradient of F cross with A. The second term, epsilon ijk ei hat del AK del xjf. So F is a constant that comes out of this. It's a scalar field, F. And what I have inside is epsilon ijk ei hat, jth component of the gradient operator, which is del del xj, kth component of vector A, which is ak. So this is curl of A. So we find that curl of FA is F curl of A plus gradient of F cross product with A. That was the first term here. I've written it as the second term here. And finally, divergence of A cross B, the del operator, del del xi ei hat, dot product with the jth component of A cross B in ej hat direction. This gives us Kronecker delta ij, which means it's ith component del del xi and ith component of A cross B. Now, A cross B written using subscript summation notation is A epsilon ijk aj bk ei hat, but I'm taking its ith component, so there is no ei hat, and del del xi. So this derivative will be applied to aj first and bk second, because it's the product of two vector fields. So that's what I did here. And in the first term, epsilon ijk bk del aj del xi, I have rearranged it so that instead of I, J, K, J, K, I, this is K, I, J. So two permutations. It's a plus one. So it doesn't change the value of the Levi-Civita symbol. Epsilon K, I, J, E, K hat. Epsilon K, I, J, B, K, del A, J, del X, I. is what I have here. So this bk ek hat is the and bk is the kth component of this vector, and here I have epsilon kij del xi ei hat aj ej hat. So that's basically this is basically what I have here is the cross product, del operator cross product with A, which is curl of A's kth component. So bk is outside, epsilon kij del xi ei has ith component, aj ej has jth component, which is what I have here. And for the second term, epsilon ijk aj, I take aj outside, and instead of ijk, I write it as jik. An odd number of permutations introduces a minus sign. Del bk del xi, I recognize that the second index is here, third index is here, which is curl of b's jth component multiplied with jth component of a. That's the dot product between a and curl of b. And for the first term here, I have the dot product between b and curl of a, and there's a minus sign in between. So divergence of a cross b is b dot curl a minus a dot curl